Lesson 2, Theoretical Probability. So to review from the last lesson, theoretical probability is what probability would be in a perfect world. So if it was perfect and it went just by statistically what it would be, how probable it is, that's how it would work. So we have the following spinner with different colors. We want to determine the probability that a spinner will stop on green. So it looks like we got a green here and a here. So we have 2 greens out of a total of 10 different things. This is the same as 1 over 5 if you want to change it. If we divide it, we can express it as a decimal, which would be 0.2. If we times it by 100, we'd get a percentage, which would be 20%. So you have a 20% chance of landing on green. Part B, determine the probability that a spinner will start on the yellow or stop on the yellow. So we have 1, 2 yellows. So again, 2 out of 10. Just kidding. It says will not stop on a yellow. So that means that there's 2 ways it can stop on a yellow, which means there are 8 ways it can't stop on a yellow. So it'd be 8 out of 10, which is 0.8. Times it by 100 and you get 80%. The last one is determine the probability that the spinner will stop on a red or an orange. So we have 2 reds and we have 2 oranges. So we have 2 plus 2 out of 10, which is 4 out of 10. Divide those, you would get 0.4. Times it by 100 and you get 40% chance. Again, if I was to spin this spinner 10 times, I might not get red and orange 4 times, but theoretically I should. Example 2. A bag of finishing nails contains 5 nails measuring 1 inch, 5 nails measuring 2 inches, and 7 nails measuring 3 inches. A carpenter randomly chooses 1 nail and does not replace the nail. He then takes a second nail. So for this one we have multiple events. We're having the first event, which is his first choice, and then we have the second event, which is dependent on what happened on the first event. So if we're going to do just part A, we want to say what's the probability that the first nail is 1 inches. So there are 5 1-inch nails out of a total of 5 plus 5 plus 7, so there's 17 total nails to start with. So we'll put the 17 on the bottom. If we were to divide those and times by 100, we would get a percentage of 29%. So you got pretty good odds there. Okay, part B. What's the probability that the second nail, after choosing the first nail has been chosen, will be a 3-inch nail? So we still have 7 remaining 3-inch nails in the bag. So there's 7 nails to choose from. However, we have 1 less nail in the bag, so it would be 16 as our total. So divide those times by 100 and we have a 41% chance now of grabbing a 3-inch nail. So separately, these 2 things have a probability. Part C is asking what is the probability that both of those things will happen. So to figure that out, what we do is we multiply our 2 fractions together. And what we should find is that it's less likely for both things to happen because there's way more restrictions being placed on this. So we have 5 over 17 times 7 over 16. To simplify this, we would multiply the tops to get 35 and multiply the bottoms to get 272. If we divide those and times by 100, our percentage would be 12.87. So it is lower, but this is how you find the percentage of both things happening. Example 3. You're rolling a dice in a board game and you need to make it to a certain square. You have 2 turns to get to this square. your 2 rolls need to get you a 5 and a 6. So let's say we're getting a 5 on our first roll. What is the probability of doing that? So there are 6 faces on a dice and only one of them is a 5, so it would be 1 out of 6. So dividing that, timesing by 100, you'd get roughly 17%. 16.67, 17%. On our second roll, we want to get a 6. So there's one way to get 6, but there's still 6 faces on the die. So this one is a little different from the last one because our total doesn't change because we're not actually taking anything away. Dice will always have 6 sides on them, and that will never change. So our second roll will be 17%. The last one says, what is the probability that you will roll a 5, and then we're going to add the word and then a 6. So we're going to assume we're going to get a 5 first and a 6 second. So this should be a lower percentage because it has more things that have to happen. So we're going to multiply both of these together. So we're going to do 1 over 6 times 1 over 6. Multiply the tops to get 1. Multiply the bottoms to get 6 times 6, which is 36. Divide these numbers and times by 100, and you get roughly 3%. So it is smaller for both things to happen. All right, last one. We're dealing with decks of cards. So if you're not familiar with decks of cards, we can go through that first. So first of all, we have hearts, we have diamonds, we have clubs, and we have spades. The hearts are red, the diamonds are red, clubs are black, spades are black. And in each set, we have the numbers ace, 2, 3, 4, 5, 6, 7, 8, 9, and 10. We count aces as a number card. And then we also have a jack, a queen, and a king. So that is the same for each suit. So we have 52 cards in total. Each suit has 13 cards. So each one of them has 13. There are 26 red cards. There are 26 black cards. We call these the face cards. And we call these the number cards. So if you need to take a picture of that or write that down somewhere, do so. We do use these often. So answering a question. You are drawing a first card. You're replacing it back in the deck and then you're picking again. What is the probability of both cards being a club? So on our first pick, we have 13 clubs to choose from, and we have a total of 52 cards. We put it back into the deck, so that means there's still 52 cards to choose from, and there are still 13 clubs to choose from for our second pick. We're going to multiply them together on the top, so 13 times 13 is 169, 52 times 52 is 2704. To divide that and times by 100, we would get 6.25%. It's like not a huge likelihood of it happening, but also not that small either. Second one, you draw the first card. You keep the card out of the deck. What is the probability of both cards being hearts? So we have 13 hearts to choose from out of 52 cards. Because we're keeping this card out now, we now only have 51 cards to choose from. But because we took a heart out, now we only have 12 hearts to choose from. So we have 13 times 12, which will make 156, over 52 times 51, which is 2652. If we divide those and times by 100, we're sitting at 5.88%. So it is a smaller likelihood. Even though this number is getting smaller, so is this one. The last one tells us that we draw the first card and it's a 5. So we don't have to worry about that. It's a 5. What is the probability of drawing the next 2 cards without replacing any cards in the deck to be both cards higher than 5? So We always are going to count ace as a 1, so it's a low card unless it tells you otherwise. So the cards that are higher than 5 are 6, 7, 8, 9, 10, Jack, Queen, and King, which is 1, 2, 3, 4, 5, 6, 7, 8 different cards, but we also have 4 suits. So that would be 8 times 4, so there are 32 cards to choose from. So for our first draw, we have 32 cards. Because this 5 has been taken out, we only have 51 cards to choose from. We're doing 2 draws, and we are not replacing, so that means I have 50 cards to choose from for my next draw, and we only have 31 cards to choose from for the remainder of the deck. So you should be able to tell that these numbers are way higher than the last 2 examples, so our percentage is going to be significantly higher. So multiply the tops, we would get 992, and on the bottom, 51 times 50 is 2550. If we divide those and times by 100, it's 38.9%. So you have a pretty good likelihood of getting a higher card there.